Hi, today I'm going to do lesson 6 from module 6, solving radical equations. I'm not using my headset right now, so I'm trying all these different ways to record, and let's see how it goes. So today you only have one vocabulary phrase, radical equation, as compared to a radical expression. Radical expressions is what we were simplifying in 6.5. But a radical equation means we have an equal sign. And you got to remember when you have an equal sign that you do the same operations to both sides. Okay? And you're going to solve for a variable. One thing about solving radical equations is, you isolate the radical on one side. Similar like when you isolate the x value or the variable on one side. Eliminate the radical, you raise, so you all know that if you have the cube root, you're going to raise it to the third power. The thing I got the highlighter for was you need to check your results. When you have a radical, especially even radicals, we're not going to have a negative answer. Square root, fourth root, it's not ever going to be -7. We're not dealing with complex numbers, okay? So if you need to check your answer, because if you go all through everything and you go back and check your answer, there's a thing called an extraneous solution that it doesn't work, it's not really a solution. All right, so let's solve this one. We'll get to extraneous solutions in just a minute. Square root of this, so same thing with operations. You're going to isolate the radicals. So here's my radical, so I'm going to subtract 2, I get 4. Now I have only the radical on one side. Oh, I have something else to say. So I'm going to square both sides because it's square root. So the radical and the square cancel each other and you get 16 here. And then you're going to add 5 and divide by 3. So 21 divided by 3 is 7. Now, we need to check because this is a square root, so we can't have a negative in the square root. If you are doing work on a test and you need to prove that you checked, I would expect to see plugging it back in for x. And you could do it in your head. 21 minus 5 is 16. Square root of 16 is 4. 4 plus 2 is 6, and it works. Some kind of work. You have to show some kind of work, especially when you have an even root, an even index. How can we change this so there's no solution? We could change this that there's no solution to have a number, x be a number that would make this negative. So if x was a 1, we could do that. I'm not doing that one. Just to think about it. What I want to tell you, though, going back to isolate the radical, in this part right here, if you have one radical, you get it on one side. It doesn't matter right or left, but you get it on one side. If you have two radicals, you need to get one radical on each side. Okay? And we don't do them, but if you had 3 radicals, you would get them like this, 2 on one side and 1 on the other side. Now I'm using all square root for my examples, but it could be cube root or whatever different index. You would just have to raise it to that power. Okay, solve a cube root. So speaking of cube roots, so our first step is to add 9. So we get 12. Remember, we leave that for last. Just like when we're solving equations, we leave the variable for last. So now we're going to divide by 4, get 3. Now this is a cube root. Just because they didn't write it like this, still the same thing. We're going to cube both sides. And here you see when you do a power to power, you multiply. 3 times 1/3 is 1, so you just have this one time. 3 cubed is 27. Then we keep on solving. Minus 6 is 21. Divide by 2, we get 21 halves for that one. Now we have to check it, and they do it on the next page. So to check it, we put in 21 halves where x is. 2 times that is just 21. So 21 plus 6 is 27. Now, PEMDAS. I'm just going to end with the PEM because E is exponent, M is multiply. Multiply is after exponent. So it's not 4 times 27. No, no, no. It is the cube root of 27, which is 3, and then you multiply. So this is the exponent, this is the multiply. 12 minus 9 is 3. They check. All right, now let's do one that doesn't work, has an extraneous solution. I don't like that the book separates them, so in the assignment, I'm having you do the mixed problems that you have to check them and see what works and what doesn't work. So here's one with 2 radicals. There's a radical on each side, okay? The 3 just stays there, that is fine. In your assignment, you have one kind of like this, which is the same thing as this. See, that has 2 radicals on the same side, so you got to subtract that one and move it over, and you end up with this. So then we have this first step, we have a square root, so we're going to square each one. This works out to this, but squaring this means I have the same thing times itself, so you had to do FOIL. So 3 times 3 is 9, square root of x times square root of x is x. But in the middle, you're going the O and the I, you get negative 3 square root of x, negative 3 square root of x, and so you get negative 6 square root of x. Now you solve it the way you know how. If I subtract x on each side, they cancel, so those are gone. If I minus 9, I get 21 minus 9 is 12. You can square it from here, but your numbers are going to be bigger than you need. Let me solve it this way, and then I'll show you how to square it. So you divide by negative 6, I get negative 2. Then I square each side, and I get 4. Now, 2 things. If you want to square it from here, you get 12 squared equals negative 6 square root of x squared, which is fine. But you get 144 equals, squaring that is 36, squaring square root is x. So your answer is 144 divided by 36, which is 4, because 36 times 2 is 72. Still get the same answer, either way. I want to show you how to find that this is not a solution. You could find it right, I guess today is Pink Day. That's funny. I'm recording this on Valentine's Day. You could find it right there. Because if I have negative 2 equals the square root of x, that's not true. So there's no solution. And 4 was my only solution. You could also plug it back in to check. This is what I would expect on a test. You put 4 in where the x is. I get square root of 25, which is 5. 3 minus square root of 4 is 2, 1. They are not true. So there is no solution because that was the only solution and it is an extraneous solution. Doesn't work. Okay. Here's another one. Several steps. They did it all, but I want to go through it. I want to point out some important steps. So we minus 8, we get 2. Now, to go from here to here, it's 2/3, so you're going to multiply by the reciprocal, 3/2, which means 6 divided by 2, or you could cancel the 2. Either way, you get 3. These cancel to 1. Then you're going to raise it to the power of 6, because it's 1/6. 3 to the 6th power is 729, minus 14, 715, divide by 11, 65. They're saying it does make the equation true, and let me show you the point that you want to check for sure. You want to check for sure when you check, you should go back to the original, because if you made an error along the way, it's going to cause a problem. Um, but in the original, this 11x plus 14 to the 1/6, since it's an even power, I can't have a negative number inside that radical. So 11 times 65 plus 14, I don't know how much that is, but I do know that it is positive, so it works. It works there. That's the only problem area I see, is the radical is an even power. Because if you have a negative number, you could take the 1/3 root. So odd indexes are fine. When you have even ones, you don't want a negative in there. So say we got a negative 65. I know how to make this that it's not true. If you were to get a negative 65, negative 65 times 11 is much bigger than 14, so you would have to take the 6th root of a negative number, which is not possible. Okay, now I'm going to show you how to solve them with calculators. So on the top of 345, page 345, I'm going to graph this to show you. Remember, you need to get 0 on one side in order to graph it. Okay, so I hope my calculator shows. Yes. So I hit the calculator button twice. I have this. Good. It doesn't have to be set. So I do control square root, because this is square root x plus 5. And then the -3, you got to make sure and hit the right arrow and get out of the radical, because the -3 is not in the radical. Now, which part are we looking for? Just like any other time that we're solving, we're looking for the x-intercept. And this looks like the x-intercept is 4. I'm kind of hesitant because in class I thought it was 2, but I don't remember for sure. But if you're not sure, you could do menu, analyze graph, 6, 0. We're looking for zeros when we have one equation. You have to tell it the left side of the 0, and then go to the right side of the 0, and it is 4. There's our intercept is 4, 0. I can't use this mouse. Oh, I guess I can. Okay. There it is, 4, 0. So x equals 4, that's the solution. That's what your x value equals. So let's go to this one by graphing. This one, they did the graph here. You could do it in the calculator, but you -9, so you get 1, and you get 0 here. So this is the part you're going to put in the calculator to graph. I know my transformations. So this move right 1 1/3, and because your h is 4/3, and up is 1, which it doesn't look like that. Oh, it's cube root. No, it doesn't look like it. Okay, forget my transformations. Look at this graph. You have the graph. You could find the 0. It's about between 1 and 2, so it's 1 and 3. 1.3, you could round about to 1.3. And remember, we're finding the x-intercepts. All right? Menu, analyze graph, intercept. I'm a little stumped on how that graph looks. Okay, so now we have 2 radicals, one on each side. If you want to move the 5 and the number, you can, but you're going to treat them like this side and this side. Make sure you have a radical on each side. So since I have 2, I'm going to graph 2 different functions. The first one, and then this is negative square root 2x plus 1. Second one, and the way you do that, I will do it to show you how to do it. I'm going to clear it, so I'm going to do menu, 1, 4, clear all this out. Now I'm going to hit tab. My first one's going to be square root of x, no, is it cube root? No, it's square root. x plus 6. Oh, didn't do it. Square root x plus 6. Move to the right. Minus, not negative, minus 5. Hit enter. There's the first one. Hit tab again. It brings up F2. This one is a negative under the 3. Square root of 2x. Go to the right. Plus 1. There it is. Now, again, they put the equation right where they intersect. Tell they intersect about here. Again, it wants to do the label, but it looks like under 4, but I can't tell the number. So I'm going to do menu, analyze graph. Now, instead of the intercept, there's 2 of them. I'm not looking for zeros because I'm going to have 2 different zeros. I'm looking for the intersection, which is 4. I'm just going to type 4. And you tell it doesn't want to look through the whole graphs because you may have more than one. So that's why you have to tell it the area to look in. So this is the area I'm looking in. And the x value, which now it's all piled up here. Let me see if I can move this. No, I can't move it, but it highlighted it. The x value is 4.02. And that is what you are solving for. So the solution is the x-coordinate of the intersection, which is 4.02. So to check it, since you graphed it, you don't have to check it because it does intersect. You get 4. I'm going to move over here on the left and say if they wouldn't intersect, if it was no solution for a system, as you know, no solution would be parallel somehow, and they would never cross. Or if you have no solution for one equation, would mean, say the square root starts up here, never crosses the x-axis. Okay? So if you graph it and they look like that, those are no solutions. All right, I'm not sure of the assignment for this one, but it is on the website and on my wall in my room. So let me know if you have questions.